Well, good afternoon, everybody. You're here, I can see you. It's not as big a crowd this morning, but I really appreciate your persistence. You're the true learners. You're the ones that stick it out, and I, as the last speaker of the day, really appreciate that. Hopefully, I will make it worth your while. I'm really excited about the work that we're doing in California. I'm excited about the ranchers and partnerships that we engage while doing that. I do work with Point Blue Conservation Science, and Rick reminded me that when I first told him about that last year is when we changed names, that I groaned along with it. You know, what the hell is Point Blue? And then it was explained to me because part of our goal with our organization is that we're no longer just a bird observatory. We no longer just use birds. We are engaged in a lot of different activities. And you can see from the map, not only in the northern hemisphere, but we do work with Bell's Pinwoods down in Antarctica. We work actually fairly significantly down in Mexico and Central and South America as well. One of our groups is our Ocean Currents group, and we work with Fish and Wildlife Service and NOAA Fisheries to help put together management for the Farallon Islands, which are a group of really biologically diverse islands just off San Francisco Bay, and the Cordell Banks, which is a protected, heavily productive fish area off of the Northern California coast. And part of our protection is we developed an app last summer you may have read about that provides shipping traffic in and out of San Francisco Bay with information about where whales are, where they are surfacing to feed on krill, and the app actually reduced the amount of whale strikes by 70% last summer. So that's just, we're no longer just a bird observatory, we're much broader than that. Part of that broadness has to do with what I'm going to talk to you about today. But to get to the point of my ramble here is that Point Blue is intended to signify what the Earth looks like from space. And if you look at a number of the climate models, if the ocean warms 2 to 3 or 4 degrees, the red algae are going to take over and the ocean will actually look purple from space. And I don't think that's anything that any of us would like to see happen. So, we want to we want to engage climate smart management, restoration, research, monitoring that we do broadly through our agency. As mentioned, we've got about 140 staff, both professional scientists and seasonal biologists. Our budget this year is about $10 million. So, we're a small, but I believe very effective nonprofit. As far as partnerships, here's a list of them. Some of them are funding partners, a lot of them are research and conservation application partners. They're fairly broad as far as who they represent, national, international, some local to San Francisco Bay. Our office is actually located in Petaluma, which is on the north bay of San Francisco, but we are dispersed. My particular office is in my hometown of Chico. I work out of my office, but I put about 2,000 miles a month on my car working with our park biologists while we work with ranchers. So, as I mentioned, that the objective of our organization is really to do climate-smart conservation actions on the land. And we all know the litany of what these stressors are, and whether, whatever your belief is about what is causing change, it's happening fairly rapidly. We're seeing a lot of very unusual weather phenomena. Just in my Northern California region last month, we got 3 tornadoes, and no one had known of a tornado happening in Northern California, up in the northern Sacramento Valley that actually did damage. There's been, funnel clouds, but nothing that hit the ground and actually, did property damage. And so these things are starting to occur with more regularity. So there's some credence to that. And of course, our drought is continuing. This map is from 2012, but More recently, this is last week's map, and you can see our region of the world, almost the entire state, is involved in really nasty drought. And you can see that our rangeland and pasture land in California is in some of the worst shape in the entire country. Now, that's the backdrop that we're working against right now with our rangeland watershed initiative. Just to give you a couple of images, you can see the date here. This is January 15th. This is on a ranch down in Mariposa County. Mariposa County is the county that you go through to get up to Yosemite National Park. This ranch is about a 5,600 acre ranch. That's the lone water source on the ranch. They've been hauling water, they've been selling cattle, but things are pretty grim. Another ranch a little bit north and west of Sacramento in Yolo County. This was taken in February. You can still see nothing green. You can see the body condition of not only the calves, but the mama cows themselves. Pretty desperate situation, so even though we got some rain in February and March, and if you drive out to California, you'll see a lot of green, but the truth is that the soil profile and the grass production really isn't what it should be and what it could be. So that's the current conditions that we have out in California. And again, I'm here to talk about our rangeland watershed initiative, and what we believe is that because of actions that we take today, many of which have been described by speakers today. We've got to really take the old models of what drought preparation and extreme weather preparation is and really look at something a little bit more adaptive than we've been thinking about in the past. So, some of the old paradigms are going to have to be shelved, and we're going to have to develop some new realities. The climate projections for California, almost all of them are suggesting that in California in the next 100 years, most of the rain in California will come as rainfall and not snow. And if any of you know about California, most of California's water historically has relied on the snowpack and the big reservoirs at Oroville and Shasta to provide water for the Central Valley Project and the Central Valley Project improvement irrigation projects, particularly for the southern part of the valley. So I'm here to talk to you about our rangeland watershed initiative. And what we intend to do with that, or the kind of shorthand for it, is Rewatering California. And I'll get into some of the specifics about that as we go through this presentation. But it's not just about water. It has to be very holistic, because in order for the soil to hold more water, the soil's got to be healthy. And one of the things that I like to emphasize in my conversation with ranchers is that soil, that adaptive layer, that soil profile is really important and largely misunderstood or not understood and largely neglected. And if we don't manage that soil profile, we can't really expect for it to give us the kinds of things we need, like water storage, like organic matter accumulation, like carbon sequestration, those kinds of things, like forage production. The one statistic I heard earlier this year is that there are more species of plants and animals in one shovelful of healthy garden soil than there is in the entire Amazon. That's pretty powerful. And yet, we use our soil, we abuse our soil, allow for high temperatures and cold temperatures without protection on the soil surface to be something that's more common than not. And so those soil flora and fauna are not being treated in ways that allow them to be healthy, that produce those amenities that we're really looking for. So our goal for, our 5-year goal for this project, and this is a project that I was hired at Point Blue to lead. Point Blue has about 50 years of research and monitoring of birds, the largest continuous data set in the United States. I think Great Britain's got some that are a little bit longer. But the problem at Point Blue is up until we started the Rangeland Watershed Initiative beginning in the late part of 2011, is that they didn't have any implementation of that conservation. But they developed a lot of research, they developed a lot of great monitoring, but it wasn't being converted into science that was being applied on the ground. And that's what we're trying to do with this rangeland watershed. This is that same area 8 years later with grazing, and nobody planted any trees. And that's when I first became aware of Point Reyes Bird Observatory, because they came in and put a bird picture on prescriptive versus ambient grazing. And we found that 8 of the 15 riparian species of concerned birds were found in these riparian areas. In similar areas, like the photograph you saw that was basically there, we found one species. So it verified what we thought was going to happen. It took a period of time for that to occur. I've got a number of pre and post grazing. I really like this photograph because, as you can see, the sedges and the rushes are starting to gather on the edges here. They're starting to grow, and what happens is when the water comes through, that slows the water down and drops the sediment. So that aggregation process is beginning to occur. And as that occurs, it's rewatering the shallow aquifers and creating hyporheic underground flow. And that underground flow and that recharging of those shallow aquifers is what allows us to have 365-day water. This is another area, pre and post. You can see this area, basically, there's no riparian vegetation. This is about 10 years later. There's water down here in the cut down side of this. You can see here's your reference on the same site. This is taken from the same bridge. Back in those days, I wasn't quite as adroit at doing my photo monitoring, so they're a little bit off, but you can see the difference. So the real key to what we're trying to do is manage surface vegetation and manage the soil surface. And I think Grady and everybody else, all of the other ranchers Dennis have talked about the importance of leaving some residue on these soil surfaces. And you can see, on this area here, this is all turkey mullein. And what happens with turkey mullein after it dies is it basically just blows away. We've got nothing but bare soil. Similarly here, this is a soil that basically had nothing on it, and there's mostly fillery and some grasses. What we'd like to see is something more on the level of what we have in these kinds of fields as far as residue. And I don't think that I need to repeat what's already been observed by Dennis and by Grady today, and also by Pat. So part of what we're doing, part of what we did with the Upper Stony Creek project is that, it's the old adage, if you don't learn from your history, you're really doomed to repeat it. And part of what I did back with Upper Stony, and I've continued to do, is really dig into the literature about what California was like, what the West was like. Not only in the Pleistocene, which is about 2 million years to about 10,000 years ago, but from the Holocene, which is about 10,000 years ago to present. So who cares? And why would I even do that? Why would we even think about that? It's because these animals really behaved in a way that allowed the vegetation that is in California now to flourish. And I've heard ranchers say, why are you talking about the Pleistocene? Because a lot of the same plants, these plants didn't just show up 10,000 years ago. Yes, the invasive Mediterranean annuals and some of the others have showed up just in the last 200 years. But the long-time natives didn't show up just 10,000 years ago. They've been on this landscape for a long time. And when you look at California's Pleistocene prehistory, it's really pretty amazing. There are at least 18 known herbivores, big herbivores, mastodons, mammoths, bison, sloth, camels, oxen, out on the landscape being pushed around by some pretty ornery predators. So saber-toothed tigers, packs of dire wolves, short-faced bears, American cheetahs. What do you think that did to the land? And how do you think those animals behave? And if that seems too obtuse and too long ago to think about, let's think about a little bit more recent. Let's think about when the first explorers got to California. There were large herds of elk, both Toomey and Roosevelt. There were large herds of pronghorn, deer, and there were big packs of gray wolves, and of course whatever's on the California flag, or California grizzly. The last wolf and the last grizzly were shot in California in 1922 and 1924. But up to that time, they were fairly common on the California landscape. How many people here have seen what a grizzly bear does to the land when they're foraging? They're not gentle. And, how many of you see where there's been a kill by wolves or grizzlies? They're not gentle. And animals react to those predators on the land. So the lesson to learn is that if we use livestock just as animals that are out there and they take what they want when they want, they go to the ice cream plants and get the ice cream plants until the ice cream plants are gone, and then they go to the plants that they like next, until those plants are gone, and then we get a proliferation of weeds. That's not going to get us to the ecological sustainability that we're looking for. We have to figure out a way to create animal impact. We have to figure out a way to use herbivory to keep the land healthy. And keeping the land healthy involves a lot of work on the rancher's part, as Dennis, Brady, and Pat have shared with us today. We're trying to do that in a way that is a step at a time, because big changes are not something that humans engage readily. Everybody stand up for me for a second. Cross your arms. Now uncross and cross the other way. Come on, you can do it. And hold it. Describe to me what that feels like. Awkward. Different. Okay, you sit down. I just want to make sure you guys want to sleep with me. But the point of it is that's the smallest change I could ask you to make. But in 5 minutes, if I say stand up and cross your arms, you're probably going to go back to doing it the way you did it, because it's comfortable. It's what you know. It's what we as humans like is our routine. So we're asking ranchers in a very high-risk business, in high-risk times, in a drought situation, to change what they're doing. And it's really, it takes some finesse to get ranchers to actually trust you and start thinking about doing their grazing, their planned grazing in a different way. And that's what we're working on, and that's why we're trying to use as many different kinds of opportunities as we can, including using history. For any of you who are interested, the Fremontia, which is the California Native Plant Society journal, back in, I believe, 1992, Stephen Edwards did an article on grazing prehistory in California, and he does a really nice job of talking about the evidence of how herbivory and animal disturbance in California really co-evolved with the plant communities that are there. So it's a good read if you're at all interested in California prehistory. But really the thing that we're working on is over this last 200 years, because of set stop grazing, because of season-long continuous grazing, a lot of the perennial elements have been eliminated from the California rangeland. And that's not just grasses, that's sedges, that's rushes, that's forbs, that's legumes, that's ferns, that's shrubs, even some of the trees are not just simply not there. And the idea is that, going back to the concept of overgrazing, it's not the range that's overgrazed, it's individual plants. And sometimes we have a little bit of a difficult time talking to the ranchers about grazing to restore and to allow the perennials that are out there to express themselves and actually start growing again. Because they'll say, well, my cows don't eat perennials. I'm sure nobody in the Intermountain West says that. But California, they say that. They really like their annual grasses. And my response is, if that's true, then why do we have cheatgrass, and why do we have star thistle, and why do we have a whole number of other invasives that are out there? They don't like those, and yet they're growing really well. So if they don't like the perennials, they should be all over the place as well, right? The truth is that the cattle do like the perennials. It depends on the time of year, but they do eat them. There's a grass in California called Muhlenberg. It's a bunch of grass that gets really big, really wolfy. And I can tell you, this winter, I saw an awful lot of deer grass that I've never seen before that is met right down to the ground. So if cattle get hungry enough, they're going to eat and actually sustain the weight with it as well. But really the key, what we're trying to do is turn our watersheds and attachments, and do that by gradually changing the plant community. And we know that the test that we have, the ranchers use out in our part of the world, is grab an annual grass and see if you can pull it out of the ground, and it pops out real easy. Put your hand around the perennial and see if you can pull that out of the ground. It just doesn't happen, because you've got that prolific root development, and what that does is it creates pore space, because most of our perennials in California die back in the summertime, and when they die back, about half the roots die. And when that happens, we create airspace, air, water, nutrients to move through, as well as increase organic matter in the soil. And that's really what we're after. So, in this photograph, the one on my left, this is a planted perennial grass, and on the other side is an annual grass. Not only is there a lot more forage on the perennial grass side, but there's a lot of cover for nesting birds and fawning cover as well. So just to give you an example, this is out of Science in 2006. This is crested wheat, and this is a regular wheat plant. The wheat is kind of a surrogate for an annual grass. And you can see this root development over a 21-month period, or actually 9-month period. And that is a photograph I showed to a lot of ranchers, and gets a lot of their attention. And that really is getting back to what we're talking about, is the key to what we're trying to do out there. In the Upper project, we actually did a rainfall simulation on these sites where we had perennials and annuals, and we simulated a 1-hour forage rainfall event on several locations in Upper Stony Creek on perennial grasses and on the annual grasses. And what we found was that on the annual grasses, we got 9 inches of infiltration, but 3.2 inches ran off. On the perennial grasses, we got 24 inches of infiltration and 0.2 of an inch ran off. So it's what Grady and Pat and Dennis are talking about, holding that raindrop where it hits and letting it get into the ground, and creating effective rainfall instead of rainfall that's running off and going, for us, out of San Francisco Bay, at a time nobody can use it, generally in January, February, March. So we do this by a series of conservation practices that we're trying to not reinventing the wheel. We are in the NRCS offices, so we use their practice standards, primarily the prescribed grazing, but also some of their other management practices like upland and wetland wildlife habitat, and like management restoration of rare and declining habitats. And we also have a lot of facilitating practices that we work on, that's fences and water developments, accelerating practices like plant range planting, some prescribed burning, some brush management. And this also has to make sense in terms of economics. And here's one economic set of statistics. This is on the 4J ranch. That after 6 years of prescriptive grazing on a 5,000-acre ranch, they went from feeding 300 tons of hay to feeding none. They increased their cow-calf herd from 300 to 500, and at the same time, they got water running in first and second order streams. It's about production, it's about stewardship, it's about husbandry, it's about staying on the land. It's also about keeping wildlife healthy, and not just things that you can hunt and fish and eat. But all the other things out there, like the pollinators that are providing ecological services, some of the other animals as well that need to make a living out there. In our oak woodland rangelands in California, we have about 330 wildlife species. It's one of our most productive, most diverse wildlife habitats in California. One of the things that what we utilize, this kind of what Robbie was talking about earlier about single species management, we do not do that at all. We've used a data set that Point Grey's Bird Observatory put together, and we use what are called bird focal species. Those are the birds that, if the landscape is healthy, they're going to be out there. And so we do point counts, which is a bird censusing, and we can tell by the point counts whether or not what's out on the land. So in other words, if the acorn woodpecker and the Nuttall's woodpeckers are out there, they're primary cavity nesters. We know that process is happening, and we also know that we'll see things like western bluebirds and chickadees and nuthatches, which are secondary cavity nesters. They rely on those primaries to do that, to build a nest, nesting cavities. We know that if we hear lark sparrows and grasshopper sparrows, that the foliar cover out there is probably 5 to 6 inches tall, because lark sparrows and grasshopper sparrows like to nest in that cover, and they like to run around and forage in grass that's about 46 inches tall. If we don't protect those, we know that foliar cover is not out there. If we don't hear valley quail, if we don't hear scrub jays, if we don't hear California toadies, we know that there's not a shrub component. Does that matter? Well, scrub jays plant about 5,000 to 7,000 acorns a year and are largely responsible for oak recruitment in California. So if the shrub component's not there, recruitment doesn't happen. So we have these focal species not only for oak woodland, but also for prairie areas, for grasslands, and for mountain meadows. And we share those with landowners, we laminate those, we throw them on the dashboard of the car, and we get a lot of questions back from them, particularly once we give them the point count data that's been taken under the radar. So the last thing that I want to talk to you about is that unlike up at Stony Creek, we really didn't take that much data. There's not much written about it, so we have engaged UC Davis, their research group at the UC Davis Rangeland Watershed Lab. That's Ken Tate and his postdoc Leslie Roach. And they're going to do a full characterization of benchmark and implementation metrics on a sets of branches and at least 3 of the work areas so we can compare and contrast. And some of the things that we're going to be looking at is soil density, some of the soil characteristics that take time for it to change. But soil organic matter, soil carbon, soil infiltration. We'll take vegetative measurements every year to track the trajectories of how vegetation is going, whether we're increasing functional roots, perennials or not, whether we're increasing or decreasing our noxious and invasive weeds. We'll be doing some hydrologic characteristics, looking at invertebrates to give us a qualitative review of how the water quality is doing on the ranches. Many of you probably know that Isaac Walton use of invertebrates to tell us how well the water quality is doing without taking expensive samples. And then I mentioned the bird point counts. We'll be doing that on every one of the ranches, either point counts or area searches, where we do a census of the birds, so we can feed back to the landowners and give them information to help course correct on their management objectives. And so these birds speak volumes by their presence or absence, and we provide that information to the ranchers, and it's really been well accepted by them the first 2 years that we've done it. And then we're working on some techniques for our partner biologists to engage the landowners for their stewardship proclivities. I really like this photograph in the middle. This is a, This is a photograph of our partner biologist taking the Point Grey's. This young lady here. Rick, is that?
Stella
Stella Leopold, all those last surviving offspring, and she was 6 of our partner biologists at the time. We put on a workshop to invite a number of Leopold scholars to help us come up with techniques of engaging landowners. And Stella said, well, my dad would say, how's the pheasant crop this year? And, just real simple, real easy techniques for our partner biologists to engage in conversations that don't have answers of yes or no, have answers that are expansive and lead to conversation. So we're using 3 unique things: the bird focal species, the Leopold land stewards, and research to support our conservation activities on the ground. And so this makes this really quite an unusual effort in terms of scope and in terms of what we're trying to accomplish. Of course, Leopold years ago recognized how important ecological integrity is, and noted it's not merely the soil that's the foundation of energy flowing through the circuit of soils, plants, and animals. So he got it a long time ago, and we're trying to build on the work that he's done and made available to us. So, time for a question? Good. It's a hedge against drought. It's a hedge against climate change. It is a hedge against losing ranches, because that's what a lot of our ranches are in danger of right now. We're in the 3rd and 4th year of drought in California, depending on the region, and it's hitting people hard. And yet, there are those producers who are forward-thinking and who have been capturing water by managing the vegetation, who are actually in pretty darn good shape. Yes. No, we have park biologists in the NRCS offices, and it's their job when they're working with the ranchers in conjunction with the range economy office and the other partners to try to engage that stewardship conversation and to suggest stewardship type activities that may not be a part of that ranch's activities. The casual suggestion. One of the things that we're doing, I didn't mention, is when you're working with a rancher, and particularly in these times of a lot of desperation, and you're talking to them about increasing vegetation and increasing water holding, and you look across the ranch, it's kind of like you can get paralyzed, like a deer in the headlights. It's like, what do I do? So we're engaging in a 1 ounce, 1 inch approach. So we walk with the landowner across the land and get them to say, we walk 3 100 pace transects across the land with the landowner, and we let them come up with what % of bare ground they've got. And then we challenge them and say, okay, so what would it take you to grow 1 more ounce of vegetation per square foot? Just 1 ounce. Anybody in math wisdom here? 43,560 divided by 16 is 2,722 pounds per acre. Over a ton of feed. 2722. A lot of these guys are feeding $300 a ton of hay. That gets them thinking, they go, I can do that. So the entree for us is, okay, how can we do that? What do we need to work with you? What is it we can do to make that happen? And then the second half of the question is, Okay, that same square foot, how could you manage your cows to get 1 more inch of water into that soil profile? Manage that surface vegetation, hold 1 more inch. And every one of them will say, I can do that. And the question is, how? And how can we help you do that? So it's not, the ranchers that we've been working with, it's sort of the light comes on, particularly the 1 ounce per square foot. And so it ends up being a matter of planning the grazing a little bit more effectively and with a little bit more attention than we have in the past, because they know what's coming in the future, which is uncertain.
Questions anymore? One last question. Over.
Yes.
So this seems like a proactive approach to drought. Do you ever think this at all as far as reactive approach to drought?
Give me an example.
I suppose I guess if it's like similar to if it's, let's say, a student drought it's not necessarily management's fault that there's a lot of it's natural environment that's a lot of
Well, Grady might argue with that, because everybody has a stocking rate out there, and the stocking rate is something that either the rancher comes up with, or he's helped come up with it, somebody assists him with that. Just to answer your question, though, we can learn from what's behind us, but we can't do anything about that. All we can do is look ahead, and that's our Robbie talked about it, Pat talked about it this morning. We're about hope. If we weren't, I don't think any of us would be here right now. We believe that we can work with those ranchers to make a difference on the land, to build resilience back into it where it's been lost, and to sustain that in time. And without that hope, we don't have a job. There's nothing for us to do. So we're not calling in. We understand what's going on out there. I've seen dead cows on too many ranches this last spring and winter to know that it's anything but real.